Okay, this next section is 8.7. Okay, so this is the last section in chapter 8. We're going to talk about another type of factoring. So it's called factoring special products. The first kind is called difference of squares. So what that means is you're going to have two terms, and it's going to be something squared, like a squared minus b squared. Difference means subtraction, so it has to have subtraction in the middle, and obviously square means these two terms have to be squared. If all those things happen, you can rewrite that as two sets of parentheses, just like we've been doing when we factor. One's going to be a plus b, and one's a minus b, okay? So that's what makes a squared is a times a, so you put one a in each. What makes b squared, b and b, okay? So look at this first one. We have 81 minus c squared. So 81 is made from 9 being squared. So we write that in parentheses so we can see it. We have the minus sign, that's good. And c squared is made from c being squared. So since those are both squareds, we can write our parentheses, put 9 squared, so 9 in each, c in each, and then 1 is plus, 1 is minus. That's it, done. Okay, the next one, 25y squared plus 1. So 25, yep, that's a squared. Y is a squared, but look at the thing that's wrong. It says plus. Okay, you cannot have addition. Difference of squares literally has the word difference in it, so you have to have subtraction in the middle. So I wrote not a difference of squares problem. So right there you just stop if it just asks you to say if it's difference of squares and solve. Next one, 64g squared minus h squared. So 64 is made from 8. See how I put the 8 in the parentheses? G squared is made from just g. So the 8 and the g are together because they were together when they were squared. Then the minus sign, and then h squared is made from h. So when you write these, the 8 and the g have to be together. They are one term. So 8g in both set of parentheses, h in both set of parentheses. 1 is plus, 1 is minus. So you have 8g minus h and 8g plus h. Okay? Next one, m squared minus 64. What makes m squared? Well, that is m and m. What makes 64? That is 8. M in both, 8 in both, both. Okay? Next, I don't know why I moved this. You could see it. Okay. Next, we have 16y squared minus 81z squared. Okay. Keep the variables with the numbers. Check and see if you get the same answer as me. You can pause it and do it. The last one's the hardest one because this is where the variables change, okay? So you look at 9 and go, okay, 9 is made from 3, b to the 4th. So with variables that aren't already to the power of 2, or really any variable, you go, okay, can that number be divided by 2? Yes. 4 divided by 2 is b squared. So that's the little term that goes to b squared is the thing in here. So that's why we put 3b squared and 3b, well, if I could write it, squared. So these both have b squareds in them. And then 25 is made from 5 and 5. So this one had squares. So if that was to the 6th, it would have been 3 and 3, right? If it was 8, it would have been 4 and 4. And just divided by 2. That's the first part. The second part is called perfect square trinomials, okay? What this means is they're just like regular trinomials where you factor, but instead of having to factor and say what times what makes this and adds up to this, there's a shortcut to it because it's made from all squared numbers. So these are the two original formulas. This is the top one, and this is the bottom one. It goes left or right. The only difference between these two is whether there's a plus or minus sign. So the first term is being squared. The last term is being squared. The middle is made by 2 times the first and the last before they're squared. So when you do this, like if you did what times what makes b squared, then adds up to the middle, it's always something times itself. So this is always a repeat number, like 8 times 8. So when we put it in the parentheses, you would notice that the parentheses would be the same. Like if you were to factor it the long way, you would notice you would get like x plus 8 and x plus 8. Same thing twice. So then it's telling you, oh, instead of doing that, we can rewrite it a shortcut way and just say, hey, that's x plus 8. And then you put a squared on the outside. That squared on the outside means I have 2 of these. It doesn't mean I only square the A and only square the B. That means I have 2 of these groups. And that's super important. We're going to do later on, okay? So then the same thing down here. The only difference is a squared minus 2ab plus b squared. That means the minus sign is in the middle, subtraction, which means it's subtracted in here. It's still squared, okay? So if you look at this first one, 4y squared plus 12y plus 9. So you ask yourself, just like we do with difference of squares, 4 is made from 2, y squared is made from y, so put in parentheses. So that's a square that works. Go to the end. 9 is made from 3 being squared, right? Just like we put in parentheses. So then you check. I did it like this in class. I went, okay, that guy, the 2, that guy, the 3. When I multiply them times 2, do I get the 12? So 2 times 2 is 4, times 3 is 12. Does that make 12? Yes. If that works, you write them as the first thing before it's squared, last thing before it's squared. Whatever this symbol is, that's what the symbol's in the middle. Done. Okay, look at the second one. 9x squared, so 9 is made from 3, x squared is made from x. 4 is made from 2, that's good. So 2 and 3, multiply me, get 6. Multiply by 2, you don't get 6. So since we multiply by 2, it doesn't make that middle number. It is not a perfect square trinomial. We can factor it for sure, but it's not a perfect square trinomial. So then we move on, because if it just says, is it a perfect square, you just stop. Now if it says factor it, find the answer, which is what we'll do later, then you can just keep going. You would just factor it the old-fashioned way. Okay? Next one, 9y squared plus 24y plus 16. So again, 9y squared is made from 3y, because 3y times 3y is 9y squared. 16 is made from 4 being squared, so we take 3 and 4, multiply by each other, that's 12. And then times 2, that's 24. That works. I put a check mark. So then I rewrite it as parentheses. 3y plus 4, all squared. Let's do a minus, a negative one. So 25x squared, subtract 30x plus 9. So 25 is from 5. X squared is made from x. 9 is made from 3. Oh, that's a cute. That's what you squared. Okay. Then 3 times 5 is 15. 15 times 2, that's 30. Sign in the middle is negative, sign in the middle is negative. Bring down the 5x, bring down the 3, put a square outside. Okay? That's the practice problems for this. Now the last thing is, we want to take everything we've learned and talked about factoring and put it all together. Let me move this up so you can see it. So, I just made a little chart here. So, number of terms. We're determining it when and what to use for factoring methods. So the method we can use all the time, no matter what, is GCF, okay? When in doubt, always start with, look at it and go, does it have a GCF? That's the question you should always either ask in the beginning or all the way at the end. Always double check. Next, 2 terms, we just learned it. It's called difference of squares, so I just wrote difference of squares. 3 terms, there's actually 2 answers for this. 3 terms, we first learned about factoring, either when a is 1 or when a is greater than 1. Also, perfect square trinomials, so technically you should make another group of 3 and write perfect square trinomials. And then the last, but certainly not least, 4 terms. The only thing that has 4 terms is grouping. So we want to first look at how many terms we have, decide which one we think of first, then do that. And then if that thing doesn't work right away, try GCF. Then go back to this. Sometimes you'll do one of these and you'll do the other. A lot of times you'll end up doing 2 of these methods in one. So let's look over here. 5x squared minus 80x. So it has 2 terms. So my first instinct would be difference of squares, but 5, not a square. So if that doesn't work, try GCF. So you go, 5 and 80, they have 5 in common, so pull a 5 out. Pull a 5 from 80, get 16. So I pulled the 5 out. Man, sorry. Parentheses, x squared minus 16. So now you ignore that 5 and go x squared minus 16. Is that squares? I thought difference of squares first time. So is x squared a squared? Yes, ma'am. Minus, good. 16 is 16 a squared. Yes, ma'am. So I keep the 5. Then I just break this down to its 2 sets of parentheses. Again, the plus and minus order doesn't matter as long as the x is in front and the 4 is in the back. Okay, next one, 9x squared minus 6x minus 35. Okay, this one is a little rough. So you first look and go, okay, has 3 terms. So that is either a regular factoring or a perfect square trinomial. Let's try perfect square first because that one should be faster. So 9x squared, those are all squares. That's good. So you go to the last term, 35. 35 is not a square. So since 35 is not a square, you go, Okay, I could probably factor it. Let's double check and make sure it doesn't have a GCF first, right, to make our lives easier. Okay, 9 and 6 have something in common, but do 9, 6, and 35 have anything in common? Well, 35 is made from 7 and 5, so no. Because 9 and 6 only have 3 in common, so no GCF. So that means the only thing we can do is factor when A is greater than 1. Take that 9, multiply it in the back, try it. It takes a little bit of work. This is my final answer. See if you get the same answer. Okay, then this is the last one I did in class. Okay, it's a grouping problem. So you have 2m cubed plus m squared minus 50m minus 25, okay? So you go, 4 terms. 4 terms means grouping for sure. Then you double check. You have to remember all of those rules with grouping. So this one only has one variable, and the only rule with variables when there's only one of them is they have to be in greatest to least form, and they already are, so you're good. So you look at the first two and go, GCF, what do you pull out? M cubed and m squared. Pull out m squared, put parentheses. What's left over? M squared, take 2 out, you got 2m left. M squared, take 2 out, you got 1 left because you took all my m's, so you still have the number 1 left. Negative 15, negative 25, they're both negative, and I want the inside to be positive, so I'm going to have to pull out a negative, and then 15 and 25 have the number 25 in common. Divide by 25, you get 2m. Divide by 25, you get plus 1 because you're dividing by negative 25. These are the same, which is what you wanted. You write the thing that's the same. Then you have m squared minus 25, and normally we would be done. But now you have to think about it. So you look at the first set of parentheses, 2m plus 1. You ask yourself, does it have any GCFs? It doesn't. Is my first term negative? No. Okay. Does this have any squares or anything I can do? Because it only has 2 terms. So the only thing I can do with factoring methods is 2 terms with squares, and this doesn't. So I bring it down and write it. Now I do the same thing here. Do these two have anything in common? No, so no GCF. Does this guy negative? Nope, so we're good there. Last, difference of squares. Are these both squares? This is a square. That's a subtraction sign. That is square. Yes, so you're going to have to actually do the difference of squares. So m squared is made from m. 25 is made from 5. So your final answer is that guy right there. Okay, take your time. We talked about it today, but you're going to be allowed to have a note card on your test and quiz, or anything like that, and this will probably start to happen more often. So you're allowed to put formulas and charts. So like you're allowed to put this chart on there. You're allowed to put these formulas up here for like perfect square trinomials because they don't have numbers on there. You can put anything on your note card, like steps when I explain you how to do things. The only thing you can't put on your note card is examples. You cannot put examples on there. So when I give you things in variable form, like difference of squares or how to factor and all of that fun stuff, I do it so you can write it on your note card or so you can learn it without numbers. So anything without numbers, and I will check it and I will give you the note card unless you don't happen to come to school, then you can do your own note card. But if you come to school normally, then I will give you the note card because I'm going to highlight a certain spot so I can find your name because you'll show it to me to prove me that you didn't put examples on it, and then I'll let you use it on the test.